Hi guys, welcome to today's tutorial. Today we'll be treating on IJMB Mathematics Questions. Get your writing materials ready with your calculators. We'll be right back. Welcome back. Our first question says, solve for x if we have 2 raised to power x plus 1 equals 8 raised to power x minus 1. So this will become 2 raised to power x plus 1. Converting our 8 to base 2 become 2 raised to power 3 bracket x minus 1. Now expanding, cancelling, equating our bases, we have x plus 1 equals 3 bracket x minus 1. Expanding this, we're having x plus 1 equals 3x minus 3. Now from here, we can collect like terms. This becomes 3x minus x equals 1 plus 3. So this will give us 2x equals 4. So x equals 4 over 2, which will give us 2. So our answer is 2. X equals 2, which is option B. If A equals 1, 2, 3, 4, we should find A inverse. So finding A inverse would imply finding the determinant of our matrix times 4 minus 2 minus 3 and 1. All right, so in doing this, we are going to calculate our determinant from here. So to find our determinant, we are having it as 1 times 4 minus 3 times 2, which will give us 4 minus 6, which gives us minus 2. So our determinant will be minus 2. So inverse of our determinant, A inverse would be 1 over minus 2 times 4 minus 2 minus 3 and 1. So minus 2, 1 over minus 2 will multiply all we have in our matrix. So this will give us our A inverse will now be 4 times half will give us minus 2. Half times minus 2 will give us 1. Minus 3 times half will give us minus 1.5. And half times 1 will give us minus 0.5. Sorry, this will be plus. Minus will cancel minus will give us plus. So our A inverse will become minus 2, 1, 1.5, and minus 0.5, which is option A. Our question 3 says differentiate y equals x cubed sine x. Now with this, we'll say let u equals x raised to the power 3 and v equals sine x. So our du dx will become 3x squared and our dv dx will become cos x. All right, now using our formula that says our du dv, du v dot times v plus our dv dot our u. All right, our next question says evaluate integral 1 of 3x squared minus 2x plus 1 dx. Now, for us to find the integral of this, we have to integrate each and every one of those terms. So first off, we have integral of 3x squared, which will give us, we know that integration is opposite of differentiation. So this becomes 3x 2 plus 1 over 3, which leaves us with x raised to the power 3. This will cancel this to give us x raised to the power 3. And if we integrate, our 2x will leave us with 2x 1 plus 1 over 2. So this leaves us with x squared. And if we integrate our 1, okay, now this will become, integrating our 1 will leave us with x, okay, because this will become our x, adding our x here will become 0 plus 1, which is x raised to the power 1, which is x. Now, having this in mind, we would know that since we are working with the integral of our limit between 0 to 1, this will become x raised to the power 3 minus x squared plus x 1 to 0, now plus x raised to the power 3 minus x squared plus x 1 to 0. Now on this part, we are going to raise x raised to the power 3 and by 1, and on this part by 0. So having that, we are going to do this as 1 raised to the power 3 minus 1 squared plus 1 squared, okay, plus 0 raised to the power 3 plus 0 squared minus 0 squared plus 0 squared. So everything here will become 0. Now, minus 1 squared will give us a plus. This gives us 1 plus 1 plus 1. Okay? So this will give us 3. So our integral of this will give us a 3. Our next question says, the general solution of the y, the x equals 3y is. Now, to solve this, we'll first of all bring our common terms y together. This becomes the y over y equals 3dx. All right, from here, we integrate this to give us integral of the y, the x, the y over y, and integral of 3dx. Okay, so if we integrate this, this gives us ny, which is going to give us 3x plus c. Okay, from here, we know that our ny positive. So from here, we take the exponents of both sides. This becomes y equals exponential of x raised to the power 3 plus c. Now this exponential can be separated to both sides. This becomes y equals e raised to the power 3x and okay, e raised to the power c. Okay, so from here, we can now say that let c equals e raised to the power c. So to replace this, this becomes our y would now give us our c times e raised to the power 3x, which is our option B. Our next question says, find the equation of the tangent to y equals x squared plus 3x at x equals 2. Now, for us to find our first point, we will differentiate this. This becomes, if we differentiate y equals x squared plus 3x, if we differentiate this, we are going to have it as 2x plus 3. Okay, so y equals 2x plus 3. So now substituting our value of x at x equals 2 to this, our y will become 2 brackets 2 plus 3, which will give us 4 plus 3, 7. Okay, now the next one, we are going to substitute for x in this equation. So y equals 2 squared plus 3 brackets 2. Now 2 times 2 will give us 4 plus 6, which will give us 10. Okay, so our values for y will be 10 and the gradient will be 7. Now using our formula that says y minus y1 equals n brackets x minus x1. Now having our x as given as 2, our y is 10, and our slope m is 7. Now substituting into this formula, all right, we are having it as y minus 10 equals 7 bracket x minus 2. Okay, expanding this, we are having y minus 10 equals 7x minus 14. All right, from here, we'll move our minus 10 over to this side. So this becomes y equals 7x minus 14 plus 10. So y equals 7x minus 4. So this is the equation to the tangent, and the answer isn't here, but this is the right equation to the tangent. Our next question says solve log 2x minus 1 plus log 2x plus 3 equals 3. Now in solving this, we are going to apply our laws of logarithm since they are of both base. Log 2 x minus 1, changing addition to multiplication times x plus 3 equals 3. Now, in order to eliminate our log, we apply our formula that says if we have log AB equals y, this becomes b equals a raised to power y. Okay, so applying this theorem or law that into this becomes x minus 1 x plus 3 equals 2 raised to power 3. Okay, now this will have, expanding this, we are having x times x, x squared, x times 3 plus 3x, 1 times x minus x, minus times plus minus 1 times 3, 3 gives us 2 raised to power 3 will give us 8. Now collecting our like terms here, we are having x squared minus 2x minus 3. Okay, sorry, plus 2x minus 3 equals 8. Okay, so we can solve out this using our quadratic formula. And the quadratic formula says that x equals minus b plus minus root b squared minus 4ac all over 2a. Where our a in this situation, our a equals 1, our b equals 2, and our c equals minus 3. Okay, now substituting into, our c will be equals plus 11 or minus 11, because if we move this 8 over to this will become minus 11. So our c equals minus 11. Okay, so 8 going over to meet 3 will become minus 8. So minus 8 plus 3 will give us minus 11 equals 0. So our full equation will be minus 11 equals 0. So our c will be minus 11. Now substituting these values into our quadratic formula, this becomes our x equals b is minus 2 plus minus root 2 squared minus 4 times a 1 times 11 minus 11. Okay, all over 2 times 1. So our x will give us minus 2 plus minus root 4 plus 11 times 4 will give us 44 all over 2. Okay, so this will give us x equals minus 2 plus minus root 48. And we are having our root 48 as x equal, over 2. So this will give us x equals minus 2 plus minus root 48 4 root 3 This will give us 6.928 all over 2. So x equals minus 2 plus 6.928 over 2, or minus 2 minus 6.928 over 2. Okay, so having this will give us 6.928 minus 2 would give us 4.928. So divided by 2, or minus 8.968 over 2. But since we are looking at logarithm, our answer can't be in negative. So this will give us 4.928. 4.928 divided by 2 would give us 2.46. Okay, so approximately to the nearest whole number will give us 3. So our answer would most likely be B, which is 3. All right, it says if z equals 3 plus 4i, find z. So since we're looking for the module of z, this will become z equals root 3 squared plus 4 squared, which will give us 3 squared, which is 9, plus 4 squared, which is 16, to give us root 25, which will give us 5. So our answer will give us 5. It says find the fifth term of a GP is 16 and the second term is 2. Find the common ratio. Now, for a GP, we know that our Tn equals ARn minus 1. Now, so for our T5, which is our fifth term, will become AR5 minus 1, which will give us AR raised to power 4. From the question, it says it's 16. And for T2, which is the second term, will give us AR2 minus 1, which is AR raised to power 1, which gives us 2. Now, they say we should find the common ratio. Now, for us to find the common ratio, we will do AR raised to power 4 over AR equals 16 over 2. So A, we cancel A, leaving us with R raised to power 4 divided by R. So this will become R raised to power 3. How? R times R times R times R over R. We cancel that one, leaving us with R raised to power 3 equals 16 divided by 2 will give us 8. So therefore, our R equals to cube root of 8, which will give us 2. So the value of our common ratio R is 2. Evaluate limit x tends towards 0 for sine 4x over x. Now, using our identity limit, we know that sine x over x equals 1. So we can separate this here to have our sine x times 4 all over x. Okay, so this gives us sine x over x equals times 4. Okay, having this, we know that this is 1. So we're having 1 times 4, which will give us 4. So our answer will be 4, which is option A. The determinant of 2 minus 3, 1, and 4 is, now to find out the determinant, we multiply this 2 and multiply this 2. So this becomes 2 times 4 minus 3 times 1, which gives us 2 times 4, 8, minus 3. Minus times minus will give us plus. So 8 plus 3 will give us 11. So our answer, the determinant of this matrix, will be 11. Solve 1 over x plus 1 over x plus 1 equals 3 over 2. Now in solving for this, we'll first of all find the LCM of these two terms. This becomes x, bracket x plus 1, all over. Now x into this, we'll be left with x plus 1, plus x plus 1 into this, we'll be left with x, leaving us with 3 over 2 as our equates. So this will give us, opening up this bracket, will give us 2x plus 1 all over x squared, x times 1 plus x equals 3 over 2. Now we can cross multiply. So this becomes 3 bracket x squared plus x equals 2 bracket 2x plus 1. Okay, now opening up this bracket, we're having 3x squared plus 3x equals 4x plus 2. Okay, now moving all our items over to one side, this gives us 3x squared plus 3x minus 4x minus 2 equals 0. So this will be left with 3x squared minus x minus 2 equals 0. So now we can now factorize this term out. Okay, factorizing 3x squared minus x minus 2 equals 0. This and this will give us minus 6x squared. And the factors of 6 that will give us 1 will be 3 and 2. Okay? Now, since this is a negative, one of them has to be a negative. So having our minus 3 as negative. Why? Because 2 minus 3 will give us a minus 1, and 3 minus 3 times 2 will give us a minus 6. So imputing this for this, we're having 3x squared minus 3x plus 2x minus 2 equals 0. So we group these two together. So here, what's common here will be 3x. This becomes 3x bracket open x minus 1 plus 2 is common, x minus 1 equal 0. So collecting these two together, we have 3x plus 2 equals 0 and x minus 1 equals 0. So from here, our x would give us minus 2 over 3, and from here, our x will be giving us 1. So the possible positive answer for x will be 1, which is option A. The derivative of tan inverse of x is, now for us to solve this, we'll start with let y equals tan inverse of x. So we can now say that tan y equals x. Okay, so from here, we can now take, if our tan y equals x, we can now find our dy dx of this. Our dy dx of tan y will give us sec squared y, and the y, our dx of x will give us the x over x, which will give us 1. Okay, so now we can now impute these two to become our sec squared y equals 1. So our, no, this should be the y dx. So having our sec squared y, our dy dx equals 1. Okay, so our dy dx will be 1 over sec squared y. Okay, now from here, we know that our sec squared y is 1 plus tan x. Okay? 1 plus tan y. Sorry. 1 plus tan y. Okay, now replacing this for this, we're having our dy dx as 1 over 1 plus tan y. But now, from here, we say let our tan y be x. Okay? This should be tan squared, sorry. Yeah. Okay? So now, from here, since our tan y is x, so we can now replace tan y for x. Our dy over dx will give us 1 over 1 plus tan y, which is x squared. So our dy dx for tan inverse of x will be 1 over 1 plus x squared, which is our option. Find the distance between the points 3, 4, and 0, 0. Now, we have our 3 and 4. This is x and y. And our next is 0 and 0. Now, since these are origin points, this will become x1, y1, x2, y2. And for finding our distance, we are using the formula d equals root of x2 minus x1 all squared plus y2 minus y1 all squared. So substituting our values here, x2 is 3 minus 0 squared plus 4 minus 0 squared. So this gives us 3 squared plus 4 squared. So 3 squared is 9 plus 4 is 16, which gives us 16 plus 9 will give us 25. So root of 25 will give us 5. So the distance between points will be 5 units, which is option. The sum to infinity of a GP is 10, and the first term is 4. Find the common ratio. Now we know that our formula for sum to infinity is S equals A over 1 minus R. Okay? Now, they've given us the sum to infinity as 10 equals our A, which is the first term, as 4 over 1 minus R. Now we cross multiply. This gives us 10 bracket 1 minus R equals 4. Expanding this will give us 10 minus 10R equals 4. So collecting our like terms, this will become 10 minus 4 equals 10R. So 10 minus 4 will give us 6 equals 10R. So our R, which is our common ratio, will become 6 over 10. Now to its lowest term would give us 2, 3 over 5. 3 over 5. And if we convert this to decimals, we are having it as 3 divided by 5. So 0.35 into 30, 6. So this is something as 0.6, which is option B. Which of these is a solution to x squared plus x plus 1 equals 0? Now to solve this out, we will use a quadratic equation, which is x equals minus b plus minus root b squared minus 4ac all over 2a. Now, from here, our a is 1, b is 1, and c is 1. Okay? Now, substituting these values into our equation, we are having x equals minus 1 plus minus 1 squared minus 4 times 1 times 1 all over 2 times 1. So this gives us minus 1 plus minus 1 minus 4 all over 2. So we'll be left with x equals minus 1 plus minus root minus 3 all over 2. Okay? Now, this will now become x equals minus 1 plus minus root 3i all over 2, which is our option B. Minus 1 plus minus root 3i all over 2. Solve 3 cos squared x minus 2 equals 0. So to solve this, this becomes 3 cos squared x equals 2. Okay, so our cos squared x equals 2 over 3. So our cos x equals square root of 2 over 3. Okay, so x will give us cos inverse of square root of 2 over 3, which is option A. What is the binomial expansion of 1 plus x raised to the power 4? All right, in order to do this, we'll multiply 1 plus x by itself 4 times. So this becomes 1 plus x, 1 plus x. Okay, step by step. 1 times 1 will give us 1 squared, that's 1, plus x. X times 1 will give us x plus x squared. So collecting these terms, we're having 1 plus 2x plus x squared. Now multiply this by another 1 plus x. Okay, 1 times x will give us, 1 times 1 will give us 1, plus 2x plus x squared, plus x plus 2x squared plus x cubed. Now collecting our like terms, this will become 1 plus x plus 2x will give us 3x plus 3x squared plus x cubed. Now multiplying this by the last 1 plus x, we are having 1 times 1, 1 plus 3x plus 3x squared plus x cubed plus x times 1, x times 3 will give us 3x squared plus x times this will give us 3x cubed plus x raised to the power 4. All right, collecting our like terms together, we're having 1 plus x, 3x plus x will give us 4x plus x squared plus this will give us 6x squared plus this and this will give us 4x raised to the power 3 plus x raised to the power 4. So this gives us our final answer. 1 plus 4x plus 6x squared plus 4x raised to the power 3 plus x raised to the power 4, which is our option A. Find the area under the curve y equals 2x from x equals 1 to x equals 3. Now, in doing this, we'll first of all integrate this. If we find the integration of y equals 2x, that will give us the integral of 2x will give us 2x1 plus 1 over 2, which is x squared, okay, plus c. Okay, that's an integration. Now, since we are looking for the value of x under the limits of 3 and 1, that will become x squared 3 and 1, which will give us x 3 raised to the power 2 minus 1 raised to the power 2. So 3 raised to the power 2 will be 9 minus 1, which will give us 8. So y equals to 2x under the area. If a is a multiple of 3, a equals multiple of 3, and b is multiple of 4. All right, it says find a intersection b. between 1 to 50. Now we are going to list out all the multiples of 3 between 1 to 50. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, and that's all. And for multiples of 4, we have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, and that's all. Now, if you're looking for A intersection B, intersection simply means what's common in the two sets. Now, looking at what's common in them, we have our 12 and we have our 24. Then what else? We have 36 and we have 48. So this is A intersection B. We have 12, 24, 36, and 48, which is option A. We've come to the end of today's tutorial. Don't forget to like and subscribe to our channel. If you have any questions or comments, put them down in the comment section below.